All right, folks, it's Bass Action, back in action here. In this video, we are going to look at how to identify the type of conic that you have simply by inspection. Now, we're specifically going to only look at conics without a rotation. We will study the rotated conics in a few lessons in a different video. But in this one, we're going to just look at how can we look at, let's say, these examples right here, these equations right here, and figure out what type of conic has been given to us. The reason that's going to help us is it's going to help us graph it. It's going to also help us understand how our final answer should look once we transform it into its standard form. So the first thing that I want you to notice is that if they have not been rotated, there will not be an XY term. So when we look at this, this is going to look like all the things that we've already seen. Each term is either an X or a Y. So just know none of these have any rotations. Up here, I've got a good little summary, but we're going to break down our problems here in a second. The first one that you would want to look for, the easiest to look for, is a parabola. Parabolas, when we look at them, will only have one squared term. You'll notice that each of these descriptions specifically talk about the squared terms, which means when we're looking at all of our equations, we actually don't care about anything else in the equation. We can just kind of mentally cover all this up. Everything that isn't squared, as far as we're concerned, doesn't even exist for the purpose of this analysis. So all this stuff really essentially goes away. Now, on the parabolas, we're looking for one squared term. So as we scan down each of these problems, we're looking for which of these only have a single squared term. I have two. Oh, here we go. Here is one that has only one squared term, so we can put a P on that for parabola. I've got two, I've got two, I've got two. Here's another one that only has one. I'm going to label that with a P for parabola. I've got two, I've got two. So we've taken care of the parabolas. If you want to find a hyperbola, everything else is going to have two squared terms. The hyperbolas are going to have two squared terms, but what's going to happen on those squared terms is the signs on them will be different. One will be positive, one will be negative. So if I take a look here at A, here's my two squared terms. Remember, there's an implied plus. So this right here is going to be our hyperbola. Now let's look and see if we've got any more. Two squared terms, but we've got a plus and a plus. I have a plus and a plus, minus and a minus. So it doesn't matter that they're negative. Their signs are in fact the same. Minus and a plus. Here's another hyperbola. So let's put an H on this one for hyperbola, and a plus and a plus. Moving on to our circle is going to have two squared terms, same sign and same coefficient, because remember, on a circle, it's going to go the same amount horizontally, that left-right, as it will up-down. So it makes sense for their coefficients to be the same. So here you go. I've got a plus, and their coefficients are both a 1. So this is going to be a circle. I'm going to put a C on that one. I have a plus and a plus, but their coefficients are different. The left-right will be different than the up-down. I have a minus and a minus, so the coefficients are the same and the signs are the same. So this is in fact a circle. When it converts to its equation for a circle, its standard form, it will ultimately equal the radius squared. But for right now, we're going to leave that just like that because that's all we're looking at. Down here, we've got a plus and a plus, but their coefficients are different. So that means that whatever is left should be an ellipse. It should have two squared terms. Their signs should be the same and their coefficients should be different. And sure enough, that's exactly what we see here and exactly what we see here. So these could both be labeled as ellipses. So this is what we would do to go ahead and identify conics just based on inspection and not having to complete the square or do any additional work.